We have a magnesium cylinder which is placed in a clamp when the temperature is 15 centigrade. And we have two steel bolts to hold the cylinder inside. We would like to learn the temperature at which the average normal stress in either the magnesium or steel first becomes 12 MPa. At first, I'm going to write the material properties. For magnesium, Young's modulus is equal to 44.7 GPa. And the alpha is 26 times 10 to the power of minus 6. And for the steel, we have Young's modulus is equal to 193 GPa, and the coefficient of thermal expansion is equal to 17 times 10 to the power of minus 6, 1 over centigrade degrees. You can find these properties from your book. We should first write an equation for the force. Let's assume that this is our shape. Since the thermal expansion coefficient is larger for magnesium, it will try to expand more. So let's draw FMG like this. And the steel bolts will try to resist. And these are the force applied by the steel. So, our total force will be 0 and it will be equal to FMG minus 2FST is equal to 0. And this will give us FMG is equal to 2FST. And let's say this force is equal to F. Also, we know that total displacement of magnesium will be equal to the total displacement of steel. We know that in 1D, strain is equal to sigma over Young's modulus plus alpha times delta T. We will multiply this by L, the length, and then we will get an equation for the displacements. Plus alpha st times delta t times L st will be equal to, now I will write minus FMG because while one is trying to expand, the other one tries to resist. Again, plus alpha mg times delta t times LMG. So we know the area of steel is pi over 4 times 10 millimeters square, and AMG is equal to pi over 4 times 50 millimeters square. And we can also calculate F. Let's suppose the stress is 12 MPa. We will multiply it by the area. Since the area of steel rods are smaller, they will reach the average normal stress first. So I am using the area of steel, but I am multiplying it by 2 because there are 2 bolts, and we will get F is equal to 1884.9 newtons. Now we have all the values to calculate delta T. And it is equal to 229 centimeters. We want to calculate the final temperature, and it will be 15 plus delta T, and it will give 244 centimeters.